So we did some chain rule examples already, but there were some very different looking chain rule problems that I saw in your homework. So I wanted to go over some of those with you. Okay, so I will do example 3 on page number 4. Okay, example 3 on page 4. Given y equals u to the 4th power, odd, right? Because usually the input variable is x, but looks like they're using u. And look at this. And u equals 5x to the 3rd power minus 2x squared. So, you can do this. If you want to skip the first part and the second part, we can go straight down to dy dx. We can write y in terms of x if we want to. So take a look. You see they said y is u to the 4th power, right? Y is u to the 4th power. But what is u? U is this. That is u. That's what they said, right? That's what u is. So I can say y is 5x to the 3rd power minus 2x squared raised to the 2nd power. And you can just do the chain rule to find this, dy dx. But why are they making us go through these 2 steps? Okay, I'll show you something cool though. Because John may wonder, okay, I get that the chain rule is derivative of the outside function times the derivative of the inside function. But why? Why does that rule work? So I'll do it using these small pieces, and we will put those 2 together. So take a look at the first part, okay? I'm not gonna do chain rule. I'm gonna follow these steps here. So first part, they want you to find dy du. What does that mean? Okay, so if you see that, bring down that y next to d du, okay? What this means is you're taking the derivative of y with respect to u. The next line, I will say what y is. I'm taking the derivative of, what is y? See, y is u to the 4th power, right? So say u to the 4th power. All right, now let's take the derivative of u to the 4th power with respect to u. That is super easy, isn't it? That is simply 4u to the 3rd power. I am done. All right, so I did the first piece, that u to the 4th power, and that is the outside function, right? Because the inside function is what u is. But now let's go down to the second line. I'll do that in orange pen. They want us to find du dx. Well, that means we are taking the derivative of u with respect to x. So what I need is I need to replace what u is in terms of x. Did they tell us what u is? Let's see. U is this chunk right there. So write down 5x cubed minus 2x squared. And that is what we are taking the derivative of. And you know how to do this. Using the power rule, this turns into 15x squared minus 4x. Alrighty, now what? How do these 2 pieces come together? Now, this time we're finding dy dx for the very last line. Now take a look at what I'm writing, okay? dy dx can be written as dy du times du dx. Okay, I had to charge my pencil for just 1 second. Okay, if you look at the diagonals, if you cancel out this du over du, what are you left with? You are left with dy dx, right? So they are the same thing. So what are we going to do? We're going to multiply the answer from the first part, which is 4u to the 3rd power. by the answer from the second part, which is 15x squared minus 4x. And I'm just going to write my answer in terms of x. So this u that we have, let's replace this u with 5x cubed minus 2x squared, and that will be the last step. Okay, so here comes the final answer. 4 times 5x cubed minus 2x squared, that is getting raised to the third power, times 15x squared minus 4x. And this would be the answer if you use the chain rule to differentiate y equals 5x cubed minus 2x squared to the fourth power. If you were to use the chain rule to differentiate this, you get dy dx as that using chain rule. So both way, it's the same thing. Oh, you're not seeing what I'm writing. Let me scroll up. But that's why the chain rule works, okay? Because we can think of dy dx as a product of dy du and du dx. So that is just using different variables, but I like chain rule. I think I'm okay with chain rule. So I'll use chain rule for maybe the next example. So it says find dy dx for each pair of function. I wonder if your homework will ask you to list dy dx and dx dt. So you know what, maybe I will do this using this pieces method and multiplying, okay? So first of all, they gave me a y in terms of x. So using this, give me 1 second, let me highlight this. Using this red piece of information, I can find them dy dx. As you can see, this is not the final answer they are looking for, but this is one of the pieces that will get me that. Dy dx is derivative of x squared minus 8x. And that is, using power rule, 2x minus 8. All right, let me go find the other piece. The x. They said x is t squared plus 6. So I can use that to find dx dt. I can take the derivative of x with respect to t. So d dt of t squared plus 6. That is 2t and plus 0, right? So that's just it. Now what? I want to find dy dt using these two pieces. Dy dt is going to be the product of dy dx and dx dt. Why? All right, see this. If dx and dx in these diagonals cancel out, what are you left with? Dy on top and dx in the bottom. That's why. So our job is to multiply this answer, 2x minus 8, by 2t. All right, so what's that going to be? I will have 2x minus 8 times 2t, and that is simply it. But all we need to do is, the variable they want the answer in is t. See right there, they want this to be in t. So what I need to do now is replace this x with something that involves t, okay? So I think they did say that the green part right there, right? They said x is the same thing as t squared plus 6. So I'll go ahead and put this in, and that will be the final answer, okay? Give me 1 second. I'll say this is the same as 2 times t squared plus 6, close parenthesis, minus 8, And I should probably draw a bigger grouping symbol times 2t. We can so simplify this, don't you think? We should simplify this. Why not? I'm going to go ahead and make my work smaller so that I can have more room. Let us simplify this. I can distribute the 2 and get 2t squared plus 12. And there is that minus 8. And outside, we have that 2t just waiting to be distributed. All right, if I simplify the inside part one more time, I will get 2t squared plus 4. And we can distribute this 2t now. If I distribute this 2t, our final answer is 4t to the third power plus 8t. And this will be the same answer that you will get if you just plug in, do you want to see? Yeah, let's do that. Why not? Why not, right? So if I move my work a little bit to the side, and I will put a line through it so that we can do this same problem using chain rule, okay? Like a little more explicitly. So y is x squared minus 8x, but they did say x is t squared plus 6, right? So y is t squared plus 6 squared minus 8 times t squared plus 6. You know what I want to do? I don't even want to do chain rule. Yeah, I think I can just FOIL it out and do the power. Let's just do that. Let's do a different method. So if I FOIL the first part, I will get t to the fourth power plus 12t squared plus 36. If I distribute the minus 8, I will get minus 8t squared minus 48. And let's combine the like terms. T to the fourth power. If you combine this one and that one, you get plus 4t squared. And if you subtract 36 minus 48, is that minus 12? Okay, so that is what y is in terms of t. If you take the derivative of that, dy dt, that is going to be 4t to the third power plus 8t minus 0, right? So is this the same as what we got using those dy dx and dx dt pieces? Yes, they are. So both are fine, I believe. If you wanted to do the second method, you had to put a put x into or you had to rewrite the y. But I think both methods are fine. I like the second one. It was a little bit heavier on algebra in the beginning, but when we get it down to just y equals, all we needed to do was the power rule, right? What left method was also very pretty, differentiating each pieces in terms of their own variable and multiplying them to find dy dt. So that was example number 4. I'll stop this one now, and because number 5 looks a little bit different. Looks like we're actually evaluating. Okay, all right.